Hello guys, welcome to the session. Today I'm going to discuss about Python for passwordless authentication and how can we implement the FIDO2 on the WebAuthn for a secure feature using the Python. So just want to give some background, right? So why passwordless? The world is pretty much digital right now, and with the increasing cyber threats and the traditional password-based authentication is no longer sufficient. The world is marching towards the passwordless authentication, and that can be achieved using FIDO2. It's something called Fast Identity Online 2 framework, and then WebAuthn ensures a strong and more secure way to authenticate the users without relying on passwords. So just imagine a world without passwords, right? So it's so cool. It's the user experience will be seamless and it's more secure. We can leverage Python and its libraries to do this seamless integration for FIDO WebAuthn using the existing authentication systems. As I said, the key benefits of the passwordless authentications includes enhanced security and then improve the user experience and then the compliance, right? All the NIST, GDPR, HIPAA, and the FIDO alliances are forcing all the organizations to follow the standards and move towards the passwordless integrations. And it also works with mobile, desktop, and web applications as well. So let's try to understand what is FIDO2 and WebAuthn, right? So FIDO2, as I said, it's a fast identity online tool. That's an open authentication standard developed by the FIDO Alliance. So by using that, we can enable the passwordless authentication by leveraging the public key cryptography. So we can go into the details and see how it works in detail. Also, we need to understand what are the key components of FIDO2. WebAuthn, the Web Authentication API, it's a standard that enables the passwordless authentication via browsers. And then there is CTAP, which is Client to Authenticator Protocol. It defines how external authenticators communicate with the browsers. So let's look at how WebAuthn works, right? WebAuthn is simply like you need to understand that's tied to the user device. So user has to register a device first. That device could be a security key or a mobile phone or your laptop or any IoT, right? So user registers with a security key or biometrics authenticator. As part of the registration, a unique public-private key pair, a cryptographic key pair is generated, and the public key is stored on the Authn server, while the private key remains securely on the device. Once the registration process is complete, then we can also look at the authentication process, right? So whenever, for example, if you want to do a Face ID authentication or biometrics authentication or retina scan or whatever it is, right? So what happens is the Authn server will send a challenge to the client, and the client signs the challenge using the private key stored in your device, and server verifies the signature using the stored public key. And if everything matches, the handshake is good, then the user is allowed to authenticate it and he'll be allowed to access the resources. So let's take a step and see how we can set up the FIDO2 WebAuthn with Python, right? So we do have many cloud providers out there. This can be, these steps, what I'm going to show now will work pretty much with all the famous cloud providers, which provides the WebAuthn and then the FIDO2 capabilities. So the prerequisites are you need to have Python 3.7 plus versions. Anything higher than 3.7 would do the job. And then you either need to have a Flask or Fast API for the backends. And then we need to also download the Python libraries for WebAuthn and FIDO2. So the installation is the first step, right? So we'll have to install the FIDO2 packages. And then we'll also take a look at the backend implementation, which is the code has been provided here. We just need to import the Flask libraries. And then also we need to import the FIDO2 server packages and the public key credential RP entity package. And then the user registration code is here. We just need to capture the user's device information and also users the public key. And then there is this user authentication flow, how the user is authenticated, and that's explained here. And to test this flow, we need to run the Flask server, and the steps are given here. And testing the authentication flow. So in order to test the deployed code, we can use a curl command or a REST API or a REST client, for example, the Postman, to send the post request to register first. As I said, the first step would be to register the user device in order to allow the authentication, the seamless authentication. And then authenticate a user is the second step. After registration, testing the authentication, test authentication using this command, right? So you are going to hit the authenticate endpoint. Again, you can request or initiate the request using the curl command or use the Postman to fire this authenticate endpoint. And this will verify the user credentials and return a authentication successful response if device provided key is matching with what we have on our side with the public key. If you want to test with security keys, for example, the security keys could be YubiKey or Titan security key. These are the physical keys where you need to plug into your device and use a browser. Pretty much all the famous browsers are supported by WebAuthn. You can use Chrome, Edge, or Firefox and follow the prompts to complete the authentication. User device compatibility and the WebAuthn support, right? As I said, WebAuthn is pretty much mature right now, and it's widely accepted by all the famous browsers across the industry. The most famous ones, as you guys know, are like Chrome, Edge, Firefox, and Safari. And then WebAuthn is also supported by Windows Hello or Guided Touch or the Android biometrics. And then there are WebAuthn is again supported by using USBs or NFC and the Bluetooth security keys. So WebAuthn, if you want to test across the devices, here is the website. It's a cool website, WebAuthn.io. You can use that website to debug the issues and look at the request and responses. And then there is a verify security key support in the browser settings as well. And troubleshooting, right? So if you guys see any issues while running the code or while registering the device or while authenticating the user, the very common issues are documented here. Security key not detected, ensure. So if you see a error saying security key is not detected, ensure that the device supports CTAP2 or invalid credentials error, and that key might not be registered properly, or we have to retry the registration. That could be a correct public key or mismatch with the keys. And then the browser incompatibility. So make sure WebAuthn is enabled in the browser settings. Okay, let me see. So best practices, always enforce the multi-factor authentication, combine WebAuthn with OTP for added security, and then use the attestations properly, validate all the authenticators using FIDO metadata service, or monitor authentication attempts, which is like implement logging for authentication failures and look at the logs and create the alerts. Probably if you're using any SIM tools, you can, if your logs are flowing into the SIM tool, make sure you create the alerts and look at the authentication failures or the attempts to flag if there are any anomalies in the requests. So overall, by leveraging the Python to implement the FIDO2 and WebAuthn, developers can build a robust passwordless authentication system that's both user-friendly and highly secure. As cybersecurity threats evolve, organizations must adopt to modern authentication methods to protect the users and data. So thank you so much for this opportunity. And if you guys want to know more about FIDO2 or anything related to WebAuthn, or if you have any questions, you can reach out to me. I'm available in LinkedIn. My ID is Sairam Durgaraju. Thanks again for attending this session.